Today we're going to go over pages 4 and 5 of our Chapter 10 notes. This is section 10.3. What we're going to find today is the remaining trig function values when one function is known. Like if you know the sign, we're going to draw a triangle and figure out all 5 of the other trig functions. So there's only 2 steps involved. Actually, there are 3. You're going to draw and label the triangle in the correct quadrant, depending on whether it's negative or positive or whatever you're told. Be careful of the signs. Use the Pythagorean theorem to find the third side, because you'll only have 2 sides of the triangle labeled. And then step 3 is use Sohcahtoa. To find the trig function values of the remaining. So in this example, we're told about the sine of theta is equal to 5/13. That's all we know. But we also, we know 2 things. We know that this angle is in quadrant 2. So we know the sine, we know the angle's in quadrant 2. So what we're going to do first is draw a triangle in quadrant 2. So you start at the origin, you go up into quadrant 2 diagonally, and remember you always drop the leg of this right triangle down to the x-axis, and the theta is the angle next to the origin. So since sine is given to us, and we know sine is the opposite over the hypotenuse, what this is saying is the opposite side of the opposite side to our angle is equal to 5, and the hypotenuse is 13. So we're going to label this opposite side as a 5 for that numerator. The hypotenuse is 13, and then we're going to do a squared plus b squared equals c squared to figure out that missing side. So b squared is equal to 13 squared minus 5 squared, which turns out to be 144. So b is equal to 12. However, we're going backwards away from on the negative side of the x-axis. So instead of 12, we're going to call this a negative 12 over here. And now all we have to do is Sohcahtoa to figure out the cosine, tangent, cosecant, secant, cotangent. So what's nice is the sine is given to us, so all we have to do is copy over sine as 5/13. And because the cosecant is the reciprocal of the sine, you can just flip that upside down and call that 13/5. Cosine is adjacent over hypotenuse, so the adjacent side is negative 12 and the hypotenuse is 13, and you flip that to get the secant, so it's 13 over negative 12. And then the tangent is opposite over adjacent, so it's 5 over negative 12, and then you flip that upside down for cotangent and get negative 12/5. And then you're all done with that problem. The next problem is secant is equal to negative 2, and theta is in quadrant 3 this time. So you're going to take from the origin, you're going to drop something diagonal down into quadrant 3. You're going to go up to the x-axis. Remember, never connect to the y-axis. It's always the x-axis, because theta is like that reference angle here. It's up against the x-axis. So if the secant is negative 2, I'm going to make this into a fraction. You can make any number into a fraction by just putting a 1 underneath it. So if the secant is negative 2 over 1, I think I'll write that down here, because I already know that's negative 2 or negative 2 over 1. If I turn the secant upside down, I get the cosine, and negative 2 over 1 reciprocal is negative 1 over 2. So from here, I can see that since the cosine from Sohcahtoa is the adjacent over the hypotenuse, what I can do is put negative 1 as the adjacent side to this angle. Here's the adjacent side, negative 1. The hypotenuse is 2. And then I can do a squared plus b squared equals c squared. So negative 1 squared plus b squared is equal to 2 squared. Negative 1 squared is 1. 1 plus b squared equals 4. So b squared equals 3. So b is equal to the square root of 3. So you might recognize this triangle as a 1, 2 squared of 3. But regardless whether you recognize it or not, now we can just do Sohcahtoa. Sine is opposite over hypotenuse. Oh, look, we're going down. If we are going down from the x-axis, this must be a negative value. So the sign is opposite over hypotenuse. The hypotenuse is always positive. Turn that upside down and you get negative 2 over the square root of 3, but we don't leave the denominator with a radical, so we turn that into negative 2 square root of 3 over 3. Now the tangent is opposite over adjacent, so we have negative square root of 3 over negative 1. Negative over negative is positive, so this square root of 3 over 1 is just the square root of 3. And the cotangent is the reciprocal of the tangent, so it's 1 over the square root of 3, positive. Rationalize the denominator and you get the square root of 3 over 3. And if you can remember about the All Students Take Chemistry, in quadrant 3, the only value that would be positive is the tangent, t for tangent, and of course the reciprocal of that, which is the cotangent. Just like back here in quadrant 2, the only thing that would be positive would be the sine. The cosine and tangent are both negative, and of course the reciprocals follow the same signs. Let's go on to the next one. The cotangent is negative 4, so I'm going to go down here and write the cotangent as negative 4, or in other words, negative 4 over 1. So you can flip that upside down back to the tangent and call it negative 1/4. And now this is a quadrant 4 angle. So we're going to draw, starting at the origin, diagonally into quadrant 4. Drop up to the x-axis. Always the x-axis, never the y-axis. Put a theta in here. And the tangent is opposite over adjacent. Well, the opposite is 1, but we're going down from the x-axis, so going down is a negative. And opposite over adjacent, this is a positive 4. Coming to the right is positive. So now we have a squared, negative 1 squared, plus b squared equals c squared. 1 squared is 1. 1 plus 16 is 17 equals c squared. So c is equal to the square root of 17. So I'm going to put the square root of 17 here. Remember, the hypotenuse is always positive. Maybe you want to write that down. Hypotenuse is, always, I think I need an E, positive, when you're labeling the sides. Okay, so now let's do Sohcahtoa. Sine is opposite over hypotenuse, so it's negative 1 over the square root of 17, but we don't leave it like that. We can call that, actually let's turn this upside down for the cosecant. So the reciprocal of this is the square root of 17 over 1, and I'm not going to put the 1 underneath here. But now we're going to rationalize the denominator, so it's negative square root of 17 over 17. The cosine is the adjacent over hypotenuse, so it's 4 over the square root of 17. Notice that it's positive. All Students Take Chemistry says cosine is positive in quadrant 2. Well, let's flip that upside down right now so we can save ourselves some work. Square root of 17 over 4. But now we're going to multiply that by the square root of 17 over the square root of 17. So we're calling that 4 square root of 17 over 17. Now we're all done with that problem. Moving on. The cosecant is 5/4. We're in quadrant 2. So quadrant 2 goes up like this. Drop down to the x-axis. Cosecant, remember, is the reciprocal of the sine, so it's the hypotenuse over the opposite. Cosecant is 5/4. Let's label that there, flip it upside down and call it 4/5. Here's theta. Sine is opposite over hypotenuse, and this is a 3, 4, 5 triangle, so I'll just label this 3. Notice it's negative because we're coming to the left. Left is negative on the x-axis. Cosine is adjacent over hypotenuse. Secant is the reciprocal of that. Tangent is opposite over adjacent. Cotangent is the reciprocal of that. And we're done with that problem. And last but not least, we have a quadrant 4 angle. So we're going to come straight down here. drop our perpendicular. Cosine is adjacent over hypotenuse. So the adjacent is 5 to that angle. Here's theta. The hypotenuse is 13. This is a 5, 12, 13 triangle. I think we've already done that in a previous example, but because we're coming down from the x-axis, it's a negative. So the cosine is 5/13. Oops, that's cosecant, sorry. 5/13. The secant is the reciprocal of that, 13/5. The sine is opposite over hypotenuse, negative 12/13. And the cosecant is the reciprocal, 13/12, negative. And then the tangent is opposite over adjacent, negative 12/5. Cotangent is negative 5/12. And that's the end of that problem. And notice in quadrant 4, only the cosine is positive. All students take chemistry says sine and tangent are going to be negative. Just like over here in quadrant 2, the only thing that's positive is sine, cosine, and tangent are both negatives. Now this last section, we're going to talk about something called an identity. Identity is just an equation that's true for any and all values of the variable, no matter what. So for example, 1/2 equals 2/4. That is an identity because that's true no matter what. But if you have something like 1 plus x equals 3, that's not an identity. That's an equation, and that's only true if x equals 2. So this isn't true for all values of x. So what we have is we have some things that we've already studied. We have something called reciprocal identities. So no matter what the value of theta is, the cosecant is always equal to 1 over the sine of theta. The secant is always equal to 1 over the cosine of theta. The cotangent is always equal to 1 over the tangent of theta. Those are things that we already know. Also, we have learned that tangent, as far as a quotient goes, is the sine of that angle divided by the cosine of that angle. It's true no matter what value of theta you put in here. And the cotangent is the upside down tangent, so we've got the cosine on top and the sine on the bottom. So that's always true. Now we have something called a Pythagorean identity, which is almost like a squared plus b squared equals c squared. But when you're talking about cosine and sine, whenever you have a cosine squared of an angle added to a sine squared of an angle, it's always going to be equal to 1 no matter what. And I'm going to show you that with the calculator. Let's see, my mode is in degrees mode, and it really doesn't matter the mode, but I'll keep it in degrees mode. Let's store an angle into our calculator's x value. Let's pick just any number like 20. Let's store 20 in for x. Now our calculator thinks x is 20. What we're going to do is we're going to do the cosine squared of x plus the sine squared of x. I'm not using theta, I'll use x in the calculator. So how do you get the cosine? You're going to do parentheses cosine x, double parentheses, and square it. That's how the calculator looks at cosine squared of an angle. And then you're going to add to that parentheses sine, and I'm going to use the value x, and I'm going to square that. So you have this cosine of 20 squared plus the sine of 20 squared. And no matter what, the answer is going to be 1. You can store any number in for x you want. Like if you want to store 80 in for x, now your calculator thinks x is 80. And if you go back and do that same exact thing with 80 equal x, it's going to come up to 1 every time. You can even put negatives in, like if you have negative 55 degrees, if you want to have x equal to a negative number, you can go back up. Your calculator now thinks it's doing the sine of negative 55 squared and the cosine of negative 55 squared, and no matter what, it's always going to be equal to 1. So that's what it means by an identity. No matter what those angles are, if you add the cosine squared plus the sine squared of it, it's going to be 1. And what you can do is you can divide everything out and get a similar identity. And if you want to divide, like if you wanted to divide everything through by cosine squared, let's say we're going to divide here, divide this by cosine squared, divide this by cosine squared, and divide this by cosine squared. All we're doing is taking each term and dividing it. You can get cosine squared over cosine squared, which is 1, sine squared over cosine squared, which is tangent squared, because sine over cosine is tangent, and since 1 over cosine is secant, this is another Pythagorean identity that can be used sometimes. And then the last thing we can do is we can divide everything through by the sine squared of theta. If we divide everything through by the sine squared of theta, this equation, cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. Anything over itself is 1, and 1 over sine is cosecant. So 1 over sine squared is cosecant squared. So those are 3 Pythagorean identities that exist. What we're going to do is we're going to take these 6 examples down below, and we're going to use some of these identities above to write in terms of sine or cosine or both. So what we're going to do is we're going to get rid of everything else that's not sine and cosine. Only sine and cosine or numbers are going to be allowed in the final answer. So what we can do is we can take secant and turn secant into 1 over cosine, because that's what secant is 1 over cosine. The cosine does not change, but what we can do to any trig function is just put a 1 underneath it. So we have 1 over cosine times cosine over 1, and cosine of theta is like a variable. You can just cancel those out, and this becomes 1 times 1, which is equal to 1. The second example, tangent is equal to sine over cosine. Cotangent is equal to both of these things, but what we're going to use is, because we only want everything in terms of sine or cosine only, we're going to use this one. So we have cosine over sine. Now, in order to add 2 fractions, you need an LCD. And the LCD is the cosine times the sine. So the LCD, we're going to say it's the cosine of theta times the sine of theta. And in order to get the common denominator, we're going to multiply this by cosine of theta. I'm sorry, we're going to multiply this by the sine of theta over the sine of theta. So now we've got the LCD here. We're going to multiply this by the cosine of theta over the cosine of theta. So now these denominators are cosine times sine. And this top, sine of theta times sine of theta, is sine squared of theta all over that LCD. Cosine of theta times cosine of theta is cosine squared of theta all over sine of theta, cosine of theta. Now they have the same denominators. Now we can just combine those numerators. Sine squared plus cosine squared all over sine, cosine. And now sine squared of theta plus cosine squared theta is equal to 1, no matter what. So we can always replace sine squared plus cosine squared with 1. 1 over the sine of theta times the cosine of theta. I kind of ran out of room here. So there's your final answer, 1 over the sine of theta times the cosine of theta, 1. The next one is a fraction. So anytime you have like a fraction you can just rewrite this as sine of theta over cosecant is 1 over sine of theta. So what you can do is you can flip this upside down, because if you divide by a fraction, all it is is multiplying by the reciprocal. So this sine of theta is this sine of theta. So we have sine of theta times this upside down is sine of theta over 1. This guy is flipped and becomes that. Sine of theta times sine of theta is equal to sine squared of theta. So there's your final answer there. The next one is tangent of theta, which is sine divided by cosine. The secant is 1 divided by cosine. Now when you multiply fractions, you multiply the top. Sine times 1 is sine of theta. And the bottom, cosine times cosine is cosine squared. Remember, you're multiplying the bottom. So that's the end of that problem. In the next one, secant is 1 over cosine. Cosecant is 1 over sine. Well, we need the LCD. Just like the other one up here above, the LCD is the cosine times the sine. So in order to get a cosine times a sine, we have to multiply the top and bottom by sine. So we're going to multiply this by sine over sine. We're going to multiply this by cosine over cosine to get an LCD. And what we have is sine times 1, which is sine, over sine cosine, the LCD. 1 times cosine is cosine over sine cosine. And now we have the same denominators, so we can just add the numerators. Sine plus cosine, and there's nothing you can do to simplify that. And on the bottom, it's sine times cosine. Do not cancel, because this is a term, right? This is a term. This is a term. Don't cancel. Right? Don't cancel those terms. That's the answer to this problem. You can't do anything else with it. And then the last one, sine. So sine can't be changed, so it's just the sine. Sometimes you can, it's easy if you just put a 1 underneath it. And cosecant is 1 over the sine. Well, you can't add 2 fractions unless the denominators are the same. So you have an LCD, which is equal to the sine. So we're going to multiply top and bottom by sine of theta. Top and bottom. Sine times sine is sine squared over sine plus 1 over sine. So when you add those two together, you're just going to say sine squared plus 1. You can't combine those or simplify those. So sine squared plus 1 all over the LCD, which is sine, and do not cancel those. Those are terms. And that's the end of that problem, and that's the end of the video. Have a good night.